we are going to look at and do some examples using operations on vectors. So when we're talking about vector operations, we're talking about stuff that's called scalar multiplication or vector addition subtraction. When we're talking about scalar multiplication, we are talking about multiplying your components by a factor, okay? And then the direction of that vector is going to stay the same. So what do we mean by that? We mean that if we were to say that k, so the variable we're using here is the variable k. So if k is a real number and we have our vector in component form, then scalar multiplication would say that we would take k times your component form, so vector 1, vector 2. And what happens is we use the same idea that we do with algebra, which says that your scalar on the outside gets multiplied to both of your components. So in other words, it's like you're distributing into your component form. So this would end up being the component k v1, k v2. That is scalar multiplication. Okay. Now when we're talking about vector addition or subtraction, we are talking about combining two vectors or more together. So here we have vector u and vector v, and so the first thing we're going to look at is how would I take my vector u plus v? Well, to do that says I have to open up my component form, and I'm going to take the first of each of my components and add them together. So this becomes u1 plus v1. Well, to put up maker the second part of our component, we now have to use the second parts. So here this is going to become u2 plus v2, and close off your component form. Now subtraction is just the same. So if we're going to do u minus v, then in this case we would use their components, so u1 minus v1, and then u2 minus v2, and close your component form. Okay, so scalar multiplication and scalar addition subtraction. So we're going to use these two ideas to run a couple of examples. So first and foremost, we have to find the indicated calculations given the following information. So here we're giving you three vectors here. So if we look at this first one, notice I have 5u minus 4v. So the first thing I would do is identify out of the problem which vectors I'm working with. So I'm working with u, which gave me the components 5 and negative 2, and I'm working with v, which gave me the components negative 4, 7. So once you know that, we have to be able to use your scalar. So the first thing that I would do is I would use the scalar on both of those before I worry about add or subtract. So with this, I have my first scalar is 5u. So if I look at that, this is going to be 5 times my component form 5 and negative 2. So when I do that, this is going to give me the new component of 5 times 5 and 5 times a negative 2. So when we actually do the math, you end up with 25 and negative 10. Now we need to look at the second one, and the second one says we're going to do 4 times v. Okay, we're not looking at the sign here, we're looking at just the k value. So in this case it's going to be 4. So we're going to have 4v. So here again this is going to be 4 times my v component, which was negative 4 and 7. So this is going to be the component 4 times my negative 4 and 4 times 7. Do the math and we end up with negative 16 and 28. Now that we have everything we need to plug it back in. So our problem said that we were doing 5u minus 4v. Well, we already calculated 5u to be the component form 25, negative 10. And we're going to subtract that from the 4v. Negative 16, 28. So when we're doing again the multiplication or addition subtraction, so here we're going to take the first terms. So I'm going to open my component form, and this is going to end up being 25 minus the negative 16. And then this is going to become negative 10 minus 28. So when we do the math, we're going to end up here with 41 and negative 38. And that was what we were looking for. So this right here is the answer to our problem. Alright, so now in this next one, we want to find the magnitude of 3w minus v. So the first thing we need to do is we need to again identify what we're using. So here we're going to use w, which was negative 1, negative 3. And then we're going to use v again, which was negative 4 and 7. So we have to do 3w. So we have 3w, which is again going to be 3 times my component form of w, so negative 1, negative 3. So this is going to end up being 3 times negative 1, which is going to give me a negative 3. And 3 times negative 3 is negative 9. Okay? So now we have to subtract it. So we're going to do our 3w minus v, which says we're going to take negative 3, negative 9, and subtract it away negative 4, 7. So let's go ahead and set that up. We've got our components, so we're going to do negative 3 minus the negative 4. And then we're going to do negative 9 minus 7. So in this case, negative 3 plus 4 gives you 1. Negative 9 minus 7 is a negative 16. Okay, so that is the component form. Now we want to define the magnitude. So the last thing we have to do here is find the magnitude of 3w minus v. So that says we are going to use the square root of your component form. So this is going to be 1 squared plus negative 16 squared. So this here is going to equal the square root of 1 plus 256, which equals the square root of 257. And that is the magnitude we were looking for. So this would be the result of this second question. Alright, now I have one other example here because sometimes we are not given the equations. Instead, we are given the vectors themselves, and we have to be able to come up with the appropriate or the correct information. So here we're giving you 2 vectors. We're also giving you your directions. So we want the component forms of negative u and 2u minus v, and then define the magnitudes of both u and v. So there's a little bit of work that we have to do here. First thing that we have to do is we have to label the points. So we have to look at everything we've got. We've got a coordinate point here, in our point here. This is our first one. So if we look at this first point, this is going to be the point 0, 1. And our second point here, we're going to count 1, 2, 3, 4, and we're going to go up 1, 2, 3, 4, 5. So this is going to be the point negative 4, 5. Now we need to do the points for our others. So we have this point here, and we have this point here, our start and stop. So the first point right here is going to go 1, 2, so negative 2, 0. And our next point is going to go 1, 2, 3, 4, and down 1, 2, 3. So we're going to have 4 and negative 3. Okay, so those are our points. Now, notice my red is labeled with the V, and my purple here is labeled with the U. So those are very important to pay attention to. So we have to go ahead and get started. The first thing that we have to do is we have to find the component forms for U and the component form for V. So let's look at the component for my vector U. So to do that says that I have to take my ending spot, so negative 4, minus my starting spot, minus 0, and do the same thing for the others. So we're going to take that ending, which was 5, and we have to subtract the starting, which was the 1. So we need to simplify this. Negative 4 minus 0 is negative 4. 5 minus 1 is 4. So the component form of U is going to be negative 4, 4. Now we need to find the component of my vector V, because we need both of those in order to do the problem itself. So again, we have to start. We're going to take our ending spot, so 4 minus the starting spot, so minus the negative 2, and then my ending spot, minus 3, minus the start, 0. So when we do that, we're going to have 4 plus 2 is 6, negative 3 minus 0 is negative 3. So we have our two components, U and V. So the first thing that we have to do is we need to translate them into our proper problems. So the first one that I have here is we have the component of negative U. So to do that says we're going to have negative 1 times my component of U, negative 4, 4. So when we apply the negative, what's going to happen is we're going to have negative 1 times negative 4 is 4. Negative 1 times 4 is a negative 4, i.e. the signs change. So that was the first piece. The second piece says that I want to find the component to 2U minus V. So this is going to be 2U, so we're going to have 2 times my U value, which was negative 4, 4, and then we're going to subtract away V, which was the component 6, negative 3. So before we do the subtraction, we have to finish out the scalar. So 2 times negative 4 is going to be negative 8. 2 times 4 is 8, minus my other, 6, negative 3. So this is going to become negative 8 minus 6, and 8 minus a negative 3. So when we simplify that, you've got negative 8 minus 6 is a negative 14. 8 plus 3 is 11. Okay, so I've got my component of negative U, I've got the component of 2U minus V. The last thing I have to do is I need to find my magnitudes. So the first thing I'm going to look at is I'm going to find the magnitude of my vector u. So I've got my vector u up here. So this is going to be the square root of -4 squared plus 4 squared. So here we're going to get the square root of 16 plus 16, which is 32. You need to reduce and simplify as far as you can. So this is going to become 4 square roots of 2. Now the very last thing that we need to do here is we need to do the magnitude of my vector v. So my vector v here is 6, -3. So this is going to end up being the square root of 6 squared plus -3 squared. So here this is going to end up being the square root of 36 plus 9, which is 45. Again, reduce that as far as you can, and we end up getting 3 square roots of 5. Now, if you go back and read your question, you will see that we've satisfied everything. First, we determined the component form of -u and 2u minus v, and then we found the magnitudes of u and v. So, -u, 2u minus v, and my 2 magnitudes. Okay? So that is a good snapshot of the different types of examples that you could see when working with different operations when dealing with vectors. Okay, so if you have any questions or if you feel the need to see additional examples, please let me know. Otherwise, I hope you enjoyed yourself and had as much fun as I did, and I will see you next time.